Everyone, welcome to, have a seat, guys. Welcome to Strictly Confidential. My name is Brady Dale. I'm one of the reporters with CoinDesk. We're here to talk about enterprise privacy, technology that enables privacy, identity, all those things, big companies. We've got Will Martino with Cadena here, Philip Shoemaker with Identity.com, and Daniel Buckner with Microsoft. Thanks a ton, everyone, for being here. It's a nice crowd for the last day of Consensus. So let's go ahead and get started, guys. We'll just go down the row with this one. First question is, we're talking about enterprise privacy. What are we talking about? Are we talking about privacy for the companies, the enterprise companies' data? Are we talking about privacy for their large business clients? Are we talking about user privacy? Like, which one is it? Let's just go down the row. Start with Will.
Sure. Thanks, Brady. The way that we talk about privacy at Cadena is that there's a spectrum to it. That you have, on one side, everything is fully public, fully replicated, everyone can see everything. On the other side, everything is completely locked down, it's all encrypted at rest. Only people who need direct access can see the data that's there. And that you can mix this approach for various use cases. And businesses need this for a variety of reasons. Sometimes it's user data, sometimes it is just internal company data. Some stuff is more sensitive than other things. You don't want to be replicating someone's social security number, let alone HIPAA compliant stuff, and not be really caring deeply about how privacy works. But every time you make something a little bit more private and you make a ledger more private, it becomes more difficult to make sure that the kind of the fundamental assurance that a blockchain provides from having perfect replication that everyone can see is still being adhered to. So you need to add other protections in.
Yeah, as Will stated, there's definitely a spectrum. And we focus mostly on individual privacy, user privacy. And I find that oftentimes in the enterprise, you see this security and this privacy roll out to the customers over time. You see it in the user's hands, et cetera. And it helps drive forward a lot of the privacy that we're involved in.
So I think we see identity as sort of the layer that bridges privacy across all the three groups you talked about, right? So there's an identity of people, things, and organizations, and how we've envisioned doing this and what we're working on is the ability to make private disclosures, claims, all sorts of stuff that is related to all three of those branches, unified under one open source standards-based approach to identity, which is kind of the sole control plane for all privacy, generally speaking.
So we've got two identity companies up here. So let's just do quickly on identity. What is the structure of how you guys provide identity services, and why is that more privacy preserving for users than the existing way in Web 2?
Well, I think with Identity.com and Civic, our belief is we don't store anything in the chain, right? And we don't have any PII in the chain. What we have is an attestation, something that attests to the fact that your identity has been validated, and you store all that on your device. And so for us, it's all about, it's not fully self-sovereign, but it's close. It's something that you have control of, it's on your device, and only you have access to it. When somebody wants to utilize that information, it's consent-based, and you allow them to get access to the information, only the information which they request, and you're notified about that.
Yeah, so very similar. I don't know if some of you may have seen the announcement we made on Monday about ION, a DID framework that runs on Bitcoin, decentralized, permissionless. It's one example of DIDs. And other groups like Sovereign and Uport also adhere to this emerging specification. And the cool thing about this particular privacy-enabling construct is that if we standardize it, it means that your interactions across apps, even beyond just claims, maybe your app data, those things become something that's more under your control, encrypted with those keys that are related to your IDs, privacy-preserving disclosures through zero-knowledge proofs. That's kind of the approach that we take to how we roll this out.
And the structure that you guys work on, I mean, tell me if I'm getting this right, but just for folks out there who are interested, the idea of self-sovereign identity, right, means that you hold something, probably in a wallet that shows who you are, as opposed to like going into a website and using a username and password and logging into their identity for you, right? That's sort of like the basic gist of it, or has it revised since then?
Well, so how it basically works is there's these constructs called DID methods. And it's how you create an ID in a system. So the thing we launched on Monday, ION, just think about that. It's synonymous with something like Lightning. It doesn't work the same, but It's just as decentralized as that. Microsoft doesn't own it. But it's one way that you can create DIDs in Bitcoin. Sovereign does it on the Sovereign ledger. Uport does that in Ethereum. All of those IDs resolve to the same, basically, control document. That is the keys and endpoints off-chain that are linked to an identifier. And you're not just going to have one of these things, by the way. You'll have multiples, maybe one for every pairwise relationship you have in the world, so that you can't be correlated, and that's another privacy-preserving feature. And then when you do disclose something from one of those identifiers from a common data set, you can give out just the piece of information you want and nothing else in a way that, again, doesn't open you up to correlation and fingerprinting.
Yeah, agreed. And the whole idea of a self-sovereign identity is something, the idea that you control it, and you control who has access to it and what type of information they get. As someone pointed out recently, it's not, as long as we're using, these identifiers are based on government documents, right? Your passports, your IDs, et cetera. As long as the government's issuing these credentials, they're not really self-sovereign, right? The government has access to them. There's a centralized database of them. But the way we store them and the way we handle them is more in a sovereign manner.
There is some confusion. I mean, the one thing I want to highlight about that, and this is something we get all the time, right? People say, well, self-sovereign identity, this is nonsense. It's not like you can just go out and mint your own driver's license.
Right.
And that's true. All we mean by self-sovereign identity is that you control your ID and the data that you have, and you can choose to disclose it however you wish. Now, to enable certain things in your life, there's going to be outside institutions, whether it's your employer or government or someone else, that's going to make a claim against an ID, like we know you're over 21, or you've shown us you have the skill to drive a car. And so it's not, and people generally calm down after you explain this. Like we talk to governments and they think it's all anarchy and you're coming to destroy us or something. It's really just, we're thinning the stack for them so that they are still in control of the assertion that you have a driver's license or you're over 21. But it's not this giant silo, and it's not balkanized across all these countries.
That's right. A lot of this information gets added over time. So for example, you may just start out with something like your driver's license and that information that's contained there. But over time, other things can be attested to, like the fact that you might have a medical marijuana card, that you might be on or you're not on the OFAC list, and things along those lines.
So I think probably a lot of folks out there are a little skeptical about the idea of big companies and privacy. Like one of the things we hear a lot in crypto land is if you're not the customer, you're the product, and that's why companies like Facebook are monetizing us so much. But even one of the big stories in the last year was we learned, I think it was mostly Motherboard that reported this, a bunch of the big cell phone companies, even though they're getting paid like $100 a month by everyone who uses them, were gathering as much data as they could and selling that off to other people. So I feel like most people, if you say, enterprises are protecting your privacy, are going to have some doubts about that. So, convince us that we're wrong. Like, why should that change?
Well, data is going to become a liability in the next decade. And that's, I think, going to be the selective pressure that pushes big corporations to really care about the privacy of their users. Right now, the Equifax hack happened. Pretty much everyone in this room, or at least I guess probably a third or a half, had some of their data exposed in that hack. And that's ridiculous. And it should be the type of thing that should have taken down the company, but it didn't. At some point, there's going to be a legal response to this, and it's going to be, data is the next oil that is going to give you all of this money. It's like, no, data is going to be the next, I don't know, we'll go with, something radioactive that'll blow up on you. And it's the type of thing that you actually want to lock down and make sure that even if you get hacked, the data doesn't actually leak out.
I mean, so from our perspective, absolutely everything you said is true. I think models will change because there's social pressure, there's pressure from regulatory agencies. A lot of people have asked me over the course of this conference after the announcement, why would Microsoft do this? Like, why would you want to preserve our privacy? Turns out we don't make our money the same way certain other organizations do. So we don't have the same incentives. And what I would tell people is, you don't trust people or organizations, you trust incentives. And Microsoft is strangely aligned in so many areas with those incentives, and that's why we see it as not only an amazing competitive advantage that we're going to fall in line with these privacy-preserving systems, but also it unlocks tons of new business, right? We don't care that the IDs are rooted in Bitcoin over a decentralized permissionless system or some other decentralized system. We don't want to own that. We'd rather support the open public utilities just like you would put phone poles up and run wire, because we're more interested in providing services on top, like signing of claims between entities. I mean, we already do this with AAD. So So I would look at people's incentives, and you'll probably understand how closely they'll adhere to these privacy.
Well, so let me pick on Microsoft and see, I'm curious about where things are going. So I'm a longtime Windows user, and a thing that didn't used to be true of Windows is you didn't need to like log in to use Windows, but now Windows pushes you as hard as it can to get you to log in and know who you are like every time you fire it up. So that feels like data is being collected for some kind of use, which I don't love. So like, how is that structure? How do you guys plan to use the technology that you're building to be able to provide probably whatever consumer benefits you get from collecting that data, but in a way that like I control? Like, what can we expect from you guys?
So one thing that we've talked about, is there's a very real possibility you could be logging in with a DID that has nothing to do with a Microsoft account soon on Windows and apps and services, stuff like that. Certainly something we discuss. The other is this idea that Satya talks about the intelligent edge. The intelligent edge is identity, completely founded in identity. The idea that your data might stay with you on a device and you could privately compute something, like let's say someone wants a credit score or something like that. If you have a bunch of claims that are cryptographic in nature, there is the ability to say, like, take down their algorithm and compute in a way that you can give them just back like a privacy-preserving statement that is a compilation of the fact that, like, yes, I should get a loan from you. And you don't have to send your data always to these giant providers to keep in a silo. So that's what we're focused on. I mean, imagine a world where Alexa or Cortana is not going to this giant cloud database all the time to go hit this huge pile of data we have, but it's actually stored locally on what we would call an identity hub or an encrypted data store that's physically on your devices.
Sounds cool. So we probably have some engineering types in the room. Maybe each of you could just give us the quick rundown of your tech stack, specifically, don't go into too much detail here, but specifically what it is about the technology that you're using that makes it good for providing good privacy for folks. We'll start with Will.
Sure. So at Cadena, we have a hybrid blockchain platform. We were kind of the first spin out from JP Morgan's blockchain R&D group. I actually got my start at the SEC. Our stack consists of PACT, P-A-C-T. It's our smart contract language. It is a Turing-complete language with built-in user formal verification. It also has a native way of describing identities and authorization logic. And on top of that, or this runs on top of two different consensus protocols. One is Scalable BFT, our private permission enterprise-grade blockchain that's been in production at Fortune 500s for a few years now. And Chainweb, which is our public proof-of-work, open, decentralized, but scalable mainnet that is going to be launching on October 30th. And the way that we approach privacy on the enterprise blockchain side is that we actually run signals encryption algorithms. So this is Ratchet or noise protocol. This is what's used in WhatsApp. Facebook uses it as well. And it is just the next gen in, effectively SSL is almost what it's been described as. We use the blockchain as a service provider. Think of it almost like a telecom. The actual ledger is just where you put the encrypted data. It's all encrypted at rest. And then you can do point-to-point or multi-point transactions that run on top of the chain itself. Also, you can always do encrypted off-chain replication of data, kind of similar to the quorum approach. And then on the public chain, you can use some of these technologies, but it's a little bit more, our public chain doesn't really have a privacy solution. We're more focused on providing a scalable smart contract infrastructure that can actually grow to meet the needs of businesses so that we don't have to worry about having a CryptoKitties app that launches on our platform, gets amazing market adoption, and then runs into the problem of, it has product market fit, and the tools let it down, and it's not able to expand as it should be able to.
Yeah, at identity.com, we're all about creating this, what we call the new identity economy, which is a marketplace. Validators and requesters can basically get on board to help drive down the cost of doing validations, to help increase the ability for everybody to get a digital ID, right? Driving down the cost allows a lot of people to be able to get on board. And we do that by bringing in a bunch of different validators and requesters and having credentials, wallets, and stuff like that. So what we do right now is we store our attestations on the Ethereum mainnet. We have an ID validator toolkit, a requester toolkit, smart contracts to handle the pricing, and how the developers that are on top of this, like Civic, for example, that's part of the identity.com ecosystem, the way they store it is entirely up to them.
So Microsoft has largely approached this. I came from Mozilla to do this work for them. Has largely approached this as a standards-first, open source-based approach, where we work in diff and W3C on emerging specs that we try and really rally both competitors and everyone in this DID space around collaboratively. So some of the foundations of that are the DID document spec that is in W3C. There's DID methods like Ion, the one that we produce that's open source, runs on Bitcoin, is not controlled by any company or institution, as well as the others that are represented in diff. The other large component that we have is this Identity Hub personal data store, again, open source. It can run anywhere. You can run it at your house. You can run it on our cloud if you choose. If you do so, your data is encrypted. We don't have the keys to it. We're more or less facilitating an endpoint that has high uptime. So we think that once these pieces are in place, then you can start doing interesting things, generating claims, having privacy-preserving apps that store its data with you and not someone else. So that's pretty much our stack.
And I know one of the things we talked about before the panel is, at least a couple of you said that these systems work best when you don't actually use you don't touch the blockchain too much. So can you guys unpack that a little bit? What are the pros and cons? And why do you need a blockchain at all then? And what do you use it for, and what else do you use?
So self-sovereignty of identity and data is fantastic, except when you think about it from the point of view of if you lose your key or you lose your phone and you remember your key, that data might be gone forever. You don't want to lose your medical records. You don't want to lose your credit history. So blockchains are very useful for pegging a representation, a cryptographic representation of Merkle root, to some public decentralized network that can then be used to go and replicate that encrypted data. So it's encrypted at rest, your data, and it can be replicated a bunch of places. And everyone can check that, okay, this thing is actually the thing that should be replicated. Kind of like BitTorrent style, except that you can then do some incentivization. So that's where the blockchain aspect of it comes in. And then because it comes from the world of Bitcoin, that blockchain really didn't make much sense as an application layer until Bitcoin became a thing, Bitcoin has this thing called SPV, or Simple Payment Verification. This allows you to go and prove that if you have a Merkle root, and you have that Merkle root that represents some big chunk of data, you can go and query that data, pick out a few pieces, and then actually provide a proof that, hey, this data that I'm giving to you, that I'm exposing to you now, is actually the stuff that is referenced on the public chain on this root that's been stored on there. And this is an incredibly powerful idea. At Kadena, we leverage this technology, or we use this technique to actually allow our public chain itself to scale, so that you can have multiple chains. We're starting right now in 20 chains being braided together in parallel, all under proof of work. But by using SPV and by using this technique, you don't only use it for privacy, but it's just for this massive level of assurance, because it allows us to scale to thousands of chains representing tens of thousands of transactions a second on a public network.
Yeah, I mean, so how we approach this is in most of the DID constructs, if it's not a specific ledger like Sovereign, who, obviously it's all crafted around that. Something like Ion, which is, an open protocol that runs on Bitcoin, is more like a layer 2. The most important thing when you use it like that is that what we're using the blockchain for is actually the Bitcoin blockchain for is actually what it was best at before it was money. Because money is a shared hallucination. It's a construct that we apply to something that we value. But Bitcoin itself was a linear chronology, like basically a decentralized clock. That's what it has always been. And so when you want to do PKI, when you want to say like what keys are associated to what ID over time, it's all about the lineage of something. So essentially, the systems that we're working on keep all the actual data off, and they root that lineage in certain points in time, and that's assembled completely off chain. You get the correct state for an ID. And when I say ID, I'm not talking about verbose identity data, like attributes about you, personally identifying information. I'm talking about mostly like routing data and keys, and that's it. So nothing that would disclose that you're a person behind this ID.
Yeah, exactly. As I stated earlier as well, we keep all PII off the chain and keep it on your device for similar reasons. We work with similar technologies, DIDs, and in order to keep everything off the chain and be able to identify who you are. What we like to store up there is the attestation, right? Just the stamp that says you are who you say you are.
So to say this back to you guys, make sure I'm following it. What you're saying is there's data gets accumulated. That data is probably accumulated somewhere off-chain, maybe copied into lots of places. And what the blockchain's good for is making people trust that it's the right thing and that it really came from the places it's meant to come from. Is that?
Well, so when using the construct of IDs, it's more about if I create an ID and I have this backing control document that says, here's the 3 keys, maybe one for my phone, one for my laptop, that prove if you asked me if I own this ID that I did, because I could sign something, right? Like Craig Wright can't. I would be able to prove to you that, and that's actually the lineage I'm talking about. So in our cases, it's mostly just for the ID itself, right?
So how far away are we from the day? So one thing I've noticed, and I guess I'm a little skeptical of in the blockchain identity process, is we hear this story a lot of times that in the world in which we're using blockchain formats to manage identity, we're not going to have to reveal as much information about ourselves anymore. But I guess I'm somewhat skeptical that that's really going to change. So I mean, a good example, just to pick on the civic identity partnership a little bit here. The first time I ever used the Civic app, I answered a series of questions until I proved I was me, which was just some things that they knew about me in the world, which was me not revealing very much. But in the phase of the Civic app that's going live to the public now, you just have to scan your entire driver's license again, which is basically, once again, revealing everything. So I don't know, like, are we really going to get this advantage of not having to reveal so much? Is that a promise that isn't going to be kept?
Well, when you reveal this information, whether it's done with the KBA, the knowledge-based authentication, or the actual credentials submission, you ultimately have to prove to someone you are who you say you are ultimately. When we go to a bar, we have to bring out our ID, which is kind of ridiculous because now this total stranger knows everything about you for the most part. They know your address. You know, they scan the ID right there. They probably are storing my credentials, and that's something that I loathe, right? I have a daughter that's about to go to college, and I know she's going to give a complete stranger her information just like that, and that's one of these things. But with the Civic or with getting your credentials submitted, sure, absolutely. It gets sent in an encrypted way to a validator who ultimately does it. It's usually done through machine learning, right? Machine vision. Ultimately does the OCR and determines you are who you say you are, checks whether the ID is valid, et cetera. And then those copies are brought back to your phone. It's stored in a protected manner, and it's stored nowhere else. So you do this once, and then when you go to a beer vending machine, which Civic has, and technologies like that, you can go up to that machine and all the information it gets is whether you're 21 or not. You know, if you're of drinking age or not, and that's for me the disclosure piece. And so yeah, you absolutely have to go through that process once. And it's up to the requester on what type of information they want. If they want solid ID, then that's what they'll have to submit a credential. If you want knowledge-based authentication, you can do that as well. If you think that's as strong. But as you know, as we often say, knowing a lot of information about me doesn't mean you are me, right? So that's why I think KBA is a little bit bad.
How can we be sure of that aspect? Where I scan my ID. I send it off to some system that gets it run through OCR. That means that you have a copy of it, and then it gets sent back to me, and then I encrypt it. How can we be sure that you didn't keep your copy? There's no way to prove it.
Granted, there's a little bit of trust here, right? And it's like any identification in general. You know, I don't trust most of the anonymous folks that hit me up with questions on Twitter or ask me for money. I don't believe those folks, right? I don't know who they are, and so you do actually have to have a little trust. Civic has a relationship with all of these validators to ensure that they delete every copy of the information they get. Again, there's a trust issue.
Hey, who are the validators? I'm actually curious.
It could be on Fido. There's a whole selection of them in identity.com marketplace. We're building this marketplace.
They're third-party companies, right? Like they're
all third parties.
Yeah, right.
And so with KBA, it could be one of these big data companies, and it could be with validators, it could be someone like Onfido.
And thanks to Daniel for being here. We were a little bit behind here, as you guys probably know, and he has a very tight flight, so he warned us he might leave early. So anyway, thanks a ton to Daniel for being here. So on this topic, this brings me to something that I am curious about. Another thing that privacy advocates talk about a lot is one of the things that protects people's privacy is if we just throw data out after a certain amount of time. It feels like if data is running through blockchains, that has a way of making it more permanent, but I might just be talking about this naively. But is there a way, A, data can still be thrown out, and B, could blockchain somehow provide us confidence that data really has been destroyed later? What's on the getting rid of data when it's no longer needed? What can you guys tell us about that?
Sadly, there's no magic here. I wish that there was. It would make a lot of use cases a lot easier. Yes, you can delete data. But the problem is that bytes and disk space are effectively free at this point, and there's very little reason to actually delete anything. So the only way that I see for really the world to understand that, yes, some stuff should be forgotten, is to make the data that's sitting on disk actually toxic, actually be a liability and a risk. And we're not there yet, but GDPR is getting it closer, and maybe over the next decade we might actually get there. But no, anyone who says that, oh, you know, we can prove that we deleted the data, no, you can't. That's just not true.
Yeah. Absolutely.
Okay, cool. And I know, Will, you said that you guys aren't doing much with your public chain in the privacy space. You're mostly relying on your private work for that. But could you guys unpack that a little bit more, because you guys are using a public chain? What's the pros and cons of public versus private blockchains for ensuring privacy?
So let me talk about a simple deployment let's talk about it in healthcare, say. So you got HIPAA compliant data. At some level, you have someone's social security number. And we're going to talk about a blockchain stack implementation in like 2 minutes. The most private stuff should never be replicated on chain, because your points of failure just strictly increase when you start replicating it. So you have some database that is siloed and is air-gapped or whatever that gives out a completely opaque identifier for what that data is. So your social security number, your blood type, whatever. Now that identifier can then go onto a private blockchain. And that private blockchain is running between probably multiple companies or maybe just internally. And the data that's found in there is more private, but it isn't so sensitive that it's a world-ending thing if it gets found out. It's the type of stuff that you want to share with the counterparty, but you don't want, but like not much more than that. You only want it to go to the people that you definitely know are in the permission network. And then you can have your application logic in a smart contract, running on that system, and you can then have a public chain that this private permission chain is linked to. And this is what we're talking about with a hybrid chain. So you have your account with, I don't know, let's go with Aetna or something, and it's a healthcare company. And they go and they integrate with Cadena with a hybrid approach. You would be able to go and interact with the smart contract that Aetna has put onto the public chain in a very controlled way, where there's very little data that's actually going out, but Aetna has control over the public chain smart contract that's linked to the private chain actual application consensus region, and also the data that's in their siloed environment. And that's when we talk about a spectrum, that's kind of what I'm meaning, where the most private stuff never goes on chain, it's just opaque. Some stuff isn't that private, but it's private enough that it shouldn't go on a public chain. And then on the public chain, you're putting as little as possible. The only things that go on there should be things that you should be comfortable with everyone knowing from now until the end of time.
It's hard to follow Will's masterclass. That's good. I like that.
Cool. Well, that's just about all the time we have. I think what we've sorted out today is that there's still a lot of moving parts in this privacy thing. It's going to be something to watch for a while, and we definitely don't have it entirely figured out yet. Thanks a ton to Will Martino of Cadena, Philip Shoemaker of Identity.com, and in absentia, Daniel Buckner with Microsoft. And thanks all of you for being here.
Thank you.